In Python, objects are an abstraction for data. Python has an amazing variety of data structures where you can use to represent data or combine them to create your own custom data. I want you to be very clear about objects in Python, so let's talk a little bit more about them. If you go to pythontutor.com, you can type the instruction into the text box and then get its visual representation. Keep this website in mind. It's very useful to consolidate your understanding of what's going on behind the scenes. I'll type age equal to 42. Then click on visualize execution. A name age is placed in the global namespace, so pointing to the object. Therefore, whenever we are going in a global namespace, after the execution that line, we can retrieve the object by simply accessing it through its name, in this case age. A first fundamental distinction that Python makes on data is about whether or not the value of an object changes. If the values can change, the object is called mutable, while if the value cannot change, the object is called immutable. It's very important that you can understand the distinction between mutable and immutable because it affects the code you write. So here's a question. I'll type age equal 42. Well, first you can type Python to enter to the CLI. Then type age equal to 42. Then print age has the value 42. Then we can say age equal 43, and we can type age again. In the preceding code, right here, had I've changed the value of age? Well, no, but probably you say it had the value 42 and then now it has the value of 43. Yes, it's 43, but 42 was an integer number of the type int, which is an immutable. So what happened is really that on the first line, age is a name that is set to the point to an int object whose value is 42. When we type age equals 43, what happens is that another object is created of the type int and the value 43. Also, the ID will be different and the name age is set to the point to it. So we didn't change that 42 to 43. We actually just create point A to different locations. The new int object whose value 43. Let's see the same code also printing the ID. Okay, I'll do the same exercise. I'll say age equal to 42 and I use a method called ID for age. Okay, it considers that ID. Now I'll type age equal to 43 and I type ID age again, and you can see that is printing different IDs. So as I told you, numbers are immutable objects. Let's talk a little more about integers. In Python, integers have an unlimited range, subject only to the available virtual memory. This means that it doesn't really matter how big a number you want to store is, as long as it can fit in your computer's memory. Python will take care of it. Integer numbers can be positive, negative, and zero. They support all the basic mathematical operations shown in the following example. So you can say uh, A is equal to 14, B is equal to 3, and then you can say A plus B for addition, A minus B for subtraction, A times B for multiplication, and also you can say A with the power of B for power operations. And also we can say well, directly 7 divided by 4 for true division. Okay, 7 slash slash 4 for integer division, and multiplication returns 1. And also you can say minus 7 with division 4. It's a true division again, but the result is opposite of previous. And check this, we say 7 slash slash 4 for integer division with applications returns 1. In this case I want to say minus 7 slash slash 4 integer division, but result not the opposite of previous. It returns 2. This is an interesting example. If you were expecting minus 1 on the last line, don't feel bad. It's just the way Python works. The result of an integer division in Python is always rounded toward minus infinity. Okay, there's also another operator to calculate the remainder of a division. It's called a modulo operator, and it's represented by the percentage sign. Okay, so we can say 10 modulo 3. The remainder of the divisions of 10 divided by 3 is 1. Also you can say 10 modulo 4, and it returns 2. The remainder of the division of 10 and 4 is 2. One nice feature introduced in Python is the ability to add underscores within numbers, literals, between digits, or base specified but not leading or trailing. The purpose of this is to help make some numbers more readable. For example, a million, like this. Okay, so you can say n equal to, then you print n and you will see a million. Okay. The same works for hexadecimal values like xm equals to I don't know, 0 x4 0 underscore underscore. Okay, xn, which it means 1024. Okay, let's talk about booleans. In Python, true and false are two keywords that are used to represent true values. Booleans are a subclass of integers and may have respectively like 1 and 0. The equivalent of the int class for boolean is the bool class, which returns either true or false. Booleans values can be combined in Boolean expression using the logical operators and, or, and not. I'll type int true, and you will see the one value. And the same way, if you print it false, you will see a 0. If you use bool for 1, it will return true. You will see bool for 0, it will return false. The same way, you can say not true, I will return false. Not false, I will return true. I will say true and true. I'm sorry, it will return true. You say false and true, it will return false. You can see that true and false are subclasses of integers. When you try to add them, for example, 1 plus true, it will return 2. Or false plus 42, it will return 42. What about 7 minus true? It will return 6. This is called upcasting. It's a type of conversion operation that goes from subclass to its parent. In this example presented here, true and false, which belongs to the class derived from the entire class, are converted back to integers when needed. Okay, now let's talk about real numbers. Usually, programming languages give coders two different formats, single and double precision. The format takes off 32 bits in memory, and in the later 64. Python supports only the double format. Let's see a simple example. I'll say, okay, real numbers. Okay, and I'll say p equal to 3.1415.9. Then radius equal to 4.5. Area equal to p times radius with a power of 2. Okay, so area will be equal to 63.61 blah blah blah. If you wanna know how a float number behaves in your computer or your system, you can type import sys, and then you will say sys.float info. Okay, let's make a few considerations here. We have a 64 bits to represent the float numbers. This means we can represent the most 2 with the power of 64 numbers with the amount of bits. Take a look at the max and epsilon values for the float numbers, and you will realize it's impossible to represent them all. There is just not enough space, so they are approximated to the closest representable number. You probably think that only extremely big or extremely small numbers suffers from these issues. Well, think again and try the following in your console. I will type 0.3 minus 0.1 times 3, and it will return this extreme number. I know this should be 0. It tells you that double precision numbers suffer from approximation issues even when it comes to simple numbers like 0.1 or 0.3. What is important? It can be a big problem if you are handling prices of financial calculations or any kind of data that needs not to be approximated. Don't worry, I mean, Python gives you the decimal type, which doesn't suffer from these issues. We will see them in a moment. Okay, by now we'll talk about real complex number. Python gives you a complex number support out of the box. If you don't know what complex numbers are, they are numbers that can be represented, expressed in the form a plus iv, where a and b are real numbers, and I or j, if you are an engineer, is a imaginary unit, that is the square root of -1. A and B are called respectively the real and imaginary part of the number. It's actually unlikely you'll be using them unless you are coding something scientific. Let's see a small example. C is equal to 3.14 plus 2.73 J. Okay. So C point real, it will return 3.14. If you type C point image like this, it will return the 2.73. Of course, you can conjugate them with the method conjugate, and if you want, you can multiply it with any number, with 2, and will return 2.28, 5.46. Well, I think that's enough. I will talk about now about fractions and decimals. Okay, let's finish the tour of number department with a look at fractions and decimals. Fractions host a rational numerator and denominator in their lowest form. Let's see a quick example for that. We can import from fractions, import fraction, okay. Okay, I'm sorry, it's fractions. From fractions, import fraction. Or you will say fraction, I don't know, 10 over 6, and I will return 5, 3. You can also say fraction 1 over 3 plus fraction 2 over 3, which is what it means. 1 over 3 plus 2 over 3. Okay, it will return something like 3 over 3, right? Of course 1 over 1. That's it. Yeah, that's it. Of course, of any fraction, for example, I said f equal to fraction, and I will use 10 over 6. You can say returns, give me the numerator, denominator, okay, and then it returns 3. Now let's see a quick example with decimal numbers. From decimal import decimal, okay, as d. We can say decimal 3.14 type p. I want to return something like this. If you type decimal of with apostrophes 3.14, you will return the exact number. Now let's type 0.1 times 3 minus the 0.3. Okay, it should return 0. You will say, oh man, it's the same, but you must do it with apostrophes to take the exact number. Okay, no approximations like this. And will return 0. Something great of this decimal if you can convert it to a fractions. For example, the I don't know, 1.4, and we see as integer ratio. Okay, I'm sorry, as integer ratio. I will return 7 over 3 over 5, which is 1.4. In conclusion, notice when we construct a decimal number from a float, it takes on all the approximation issues floats may come from. On the other hand, when decimal has no approximation issues, for example when we fit an int or a string representation to the construction, then a calculation has not quirky behaviors. When it comes to money, use decimals.